Hi. In this video, I'm going to be going through weather routing in a little more detail. I'll take an example from San Francisco to Hawaii and start from scratch and build up the route slowly. So the first thing to do, I've already downloaded a GFS weather file with the full 16 days of forecast. And looking at it briefly, as you would expect, there are trade wind conditions to the east of Hawaii. So one general strategy would be to leave San Francisco and head down to that area pretty quickly, and then hope that once you're down there, what the forecast is showing will actually be what you expect, what you experience down that area. Alternatively, if you were to leave San Francisco and head straight west and then plan to turn and come down heading south to Hawaii, then this whole area north of Hawaii is an area full of uncertainty. And you have areas of very strong wind. Looks like at least gale force north of Hawaii at that point. 50 knots of wind, yeah, you want to avoid that. And we go from westerly winds to southerly winds and easterly winds and light patches and strong patches. So I think generally we're going to want to avoid that whole area. So having looked at it briefly, let's see if we can use the weather router to give us a hand. So we'll move into the weather routing tool, and there's nothing set up at the moment. So I'll use this default vessel, which is set up for you. Open up the settings, and at the moment it's set to the default cruiser. So I'll accept that. We'll come back to this a little bit later. This default cruiser has a cruising speed of around 8 knots, which is pretty quick for a cruising boat. And we'll come back and look at that in a bit more detail later. I'm going to be always sailing, so we'll look at motoring a bit later as well. I'm going to avoid wind speeds greater than 30 knots apparent. You can choose a true or apparent for that. And aside from those, I'll use all the other defaults. I want to start in San Francisco, so I'll zoom into the map of that area. Click down in the map, bring up the menu, and choose Create Start Point. So there's a start point. I'll move the time in the grid timeline to the start of this forecast interval. Click again in the map, and use the menu item Set Time. Set start time from timeline. So now we have a start time set. And while we're at it, we'll give it a destination to head towards. And we'll go to, I think, Hanalei Bay on Kauai. So we'll zoom into Hanalei and give it a target point there. So yeah, that's it. We have weather data. We've described to the system what the boat's performance is through a polar diagram. We've given it a start point, start time, and a target point. So that's solved. So now the optimizer is going through and looking at all the different solutions, and here it is. So the isochrones are large. Leaving San Francisco, they head off in all different directions, but there's no path. It didn't create a path to Kauai. So let's zoom in to Kauai briefly and have a look. So the isochrones coming into Hanalei Bay seem to stop. They pile up and making very little progress. So let's click down the map, ask it to set the grip time corresponding to the cursor location. And now we see that there's no wind at the destination at this time. So the vessel was up here, it was traveling in winds of 5 knots. I'm reading that from the text to the right of the screen. Information at cursor. You can move the cursor around and have that information show you the conditions at that point. So at this point, the winds were 6 knots, and then as we go south, the forecast progresses to the point where there's just no wind. So yeah, we'll come back to that in a minute. We'll have the boat motor, or allow it to motor as well. But even with this, there's no path being generated, but there's already some information being shown. So let's look at, we'll change the display to show the true wind speeds. And we'll place the cursor towards the destination. So you can put the cursor wherever you want in this whole solution space, and the system will show you the optimized path to that point. So placing the cursor at Hanalei Bay, we see that the system is showing us a path which is ending up north of Hanalei and then turning and heading directly south towards Hanalei, which is that's one possibility, I guess. We generally want it to stay further south, get into the trade winds. And at this point, we're looking at forecast data, which is 15 days into the forecast. So there's a great uncertainty with this forecast data. You don't really want to be making plans on your first day of travel based on what this forecast is showing 15 days from now. There's much more certainty with the forecast data for the first few days, and then the uncertainty grows and grows and grows. So making a decision based on the 15-day forecast data early in your journey is generally a bad idea, because there's a great possibility that this forecast, the data showing at this time, will be different by the time we get to that time. So let's just look around a little bit, move the cursor, and here there's a big discontinuity at this point. So I have an earlier video talking about zippers. Zippers happen in areas where there's some kind of block in a weather pattern, which forces the fleet, the isochrones, to wrap around a point from different directions. So if I move the cursor slightly in this area, there's a big discontinuity in the path. The path goes from heading from far north of Hanalei, turning and heading south towards it. Or if I just nudge over a little bit to the east, now it's deciding to approach Hanalei from the east. So I like that path. It generally lines up with our strategy we looked at the start of the video. And if I keep on searching, if I was to approach Hilo, this path leaves San Francisco and heads generally, southwest it looks like, whereas this path is leaving San Francisco and heading pretty much southwest. So if we use this path, leaving San Fran, we would head southwest. If we prefer these paths, we head more south-southwest. Let's back up a little bit. And if I read the text at the bottom of this information at cursor area, it shows the travel time. So the travel time to get to this cursor area is 10 days, which again has great uncertainty in this data. So you don't want to be making decisions early in your passage based on this data. There's a lot of uncertainty still. But looking around, this is more stable in this area. Looking at the path early in the passage to get to this trade wind area, seems like all of these tend to leave San Fran and head southwest or so, and then heading north into this area of more uncertainty, which we tended to want to avoid. That's when we start to head more southwest from San Fran. So these all tend to leave San Fran and head more south. And then if we go at this point, now we're 4 days into our passage, and most of these areas, which we think we prefer to be in, are all pretty stable. If you look at the start of that path, as we move the cursor around, it doesn't change that much. And then as we head more north, it starts to make more changes. So I think based on this, we don't want to end up anywhere this far north. There's a pretty strong preference to head south into the trade winds and then head over to Hawaii. So one way to express a preference to the router is to create a constraint. And this is unique to LuckGrib. So I've just moved over to the Points and Routes tool. I'll click down, have it create a constraint sequence. And then here's a constraint. which I'll place. Oh, I don't know. We can move this around, but as a first experiment, we'll put it here somewhere. And what I want to do is leave San Francisco, and as I pass this point, I want that point to be on my starboard. So I'll double click on that point and then say, tell it to leave point on starboard. So now we have a S2 of the triangle. Put it there somewhere. I'll give it a name quickly. Just call it NP, North Pacific. And I'll move back to the weather routing tool, open up the settings, and I'll come down and choose that as my constraint sequence. You can add more than just that one point. I could add points all along this route to shape it as I want. But yeah, that's the first one. So now I want to leave San Francisco, and I only want to see solutions which leave this point to my starboard. So yeah, there we go. Let's have a look at this. So now now we have a path. Before there was no path being generated, but now it was able to find a path, which is interesting. Zooming into the target, the system's being a little helpful. It's choosing this path even though it's fairly far from the actual target. The target's still in this area of very light wind. Let's go back to looking at the group file. So yeah, as we have the group file update for the path, we're seeing light winds in this area. So the vessel slowed down dramatically as it got there. And this is, yeah, it ran out of forecast time. So we'll come back and try motoring there in a bit. But let's take a look at this. So now we're leaving San Francisco. Oh, it's very light wind here as well. Oops. Leaving San Francisco in light winds and then heading south. I shall go to this image which shows me the true wind speed. So yeah, there's the blues indicate very light wind. So yeah, we start in very, very light wind. We may want to motor it at the start to get going. Then head more quickly off into stronger winds. And then we're in decent wind for a while. And from there on, we tend to avoid. There was a light patch it was trying to route through earlier. And now it's avoided that by our telling it to stay south to keep this point on our starboard. As we approach that point, the isochrones still have a full search space. They're searching for a solution everywhere. As we come to that constraint point, the system realizes that all of the points now which had that point to the report they don't work because they don't match that constraint. So the isochrones come up to the constraint point, and then the ones which did pass it continue, and the other ones don't. So now we're approaching, now we approach Hawaii. Beautiful. This last little bit is interesting. So we mentioned that, the start and end of this trip are in light wind. So let's allow this boat to motor. So at the moment it's set to always sail. I'll change that to motor if sailing speed falls below. And I'll make it 2.5 knots. By default, it'll turn on the engine immediately once the boat speed falls below 2.5. But I'll give it 3 hours. I don't mind bobbing around a little bit. I prefer to sail the entire distance. So if I bob around more than 3 hours, I'll get impatient and turn the engine on to find more wind. That seems fair. The system has this highlight in red, so I need to give it a performance diagram for the engine. And I've set this to motor at 5.5 knots. So that's fine. Let's do that. Resolve. And here's the new solution. So let's change the image to show us what parts we're motoring and what parts are sailing. So now it still is sailing at the very beginning. True wind here is 6 knots, and we're traveling 5. This is a pretty fast boat. And then we end up in this area of slow wind. So this orange indicates the boat is traveling slower than its 2.5 target. But it's in this waiting period. It's still waiting for that 3-hour interval to expire. So the orange, it's kind of moving slowly. It finally hits 3 hours, and the purple indicates it's motoring. So now we're going at 5.5 knots. So finally we end up with no more motoring. We end up sailing again. The green is sailing. And we seem to sail for the rest of the passage until the very end. So as we approach Hawaii, again, there's a little interval here where it's sailing slowly, and then it gets fed up and turns the engine on, and then motors towards the destination. So if we look at the details, this solution has a motoring time of 12 hours. So depending upon how much fuel you burn per hour, that could be something like 6 gallons. That's not so bad to get to Hawaii. You can also do a comparison, so you can have the system generate both of those solutions, the sailing solution and the motoring solution. So there's an option in this routing ensemble settings area to try generating routes with and without motoring being allowed. So now if I have the system resolve, it should generate 2 solutions. There's one. And there's the second one. And here they are. So this first one that's highlight has the 12.6 hours of motoring. The sailing solution, as you would expect, has none. The difference in time is 15 days, 14 hours for the motoring solution, and 15 days, 20 hours. So it's a 6-hour difference in time for the passage for 12 hours of motoring. So seeing that, you may choose, well, you have choices about when you actually start motoring. You don't need to look at this data and decide based on what this says when you start and stop motoring. You can make those decisions for yourself, of course. So at the end, if you have a large fuel tank, this end point where you're bobbing around, sailing slowly, only to start motoring a bit later, you may decide that since you're going to be sailing soon anyway, you might as well start earlier on and just get there. Of course, if you're racing, that's not really a possibility. Let's go back to the other image. We look up and downwind. So we'll do a pure sailing solution. So how's it look for our travel? So we're, this green indicates pretty much winds on the beam. We're reaching winds. Greens we're reaching pretty much. So we're looking at true winds. We'll look at apparent winds, upwind, downwind. So it's kind of upwindish, reaching, lots of greens, lots of reaching, and then towards the end, we hit these blues. So now we're running, and we pretty much some more reaching. Oh, and the end of it is back to winds are upwind. Actually quite upwind. These oranges and reds are winds far forward. So it's going to end up being quite a wet ride towards the end of this passage. Hopefully there's a freshwater shower waiting for us at Hanalei. So that's all based on this default vessel. I'll quickly look at the performance for this vessel. So if you open up this settings, the vessel settings area again, and click the arrow to the right of performance, here's a polar diagram for this vessel. So when you're choosing a polar diagram, and I'll talk more about this in a future video, because it's quite a large topic and I don't want to spend too much time on here, but there's a catalog you can look through to find a polar diagram which roughly matches your vessel. And if your vessel has a similar performance to this, but it's slower, you can quickly shape this. So my vessel, my sailing boat, Luck Ness, isn't able to sail 8.3 knots. Its maximum speed's more like, well, I can do 7, but I prefer to keep it lower to avoid wear and tear. So you can quickly change the maximum speed. In this case, I've made it 6.5, and the whole shape of the diagram remains the same, but it's scaled down. So now the maximum speed is 6.5. So if you find a polar diagram in the catalog, which has a good shape for your vessel, but it's too slow overall or too fast overall, you can quickly change it. And the polar diagram, the polar catalog is found in this polar diagram manager, the second tab over. And now there's a whole list of these vessels here. And as we look through them, I'll spend more time discussing what the shape of these things mean. But when you see these performance lines end up being very uniform in this downwind area, the bow of the boat's in the front on top here, and the stern of the boat's on the bottom. So this line being so smooth towards the stern of the boat indicates there's a spinnaker. So you can fix that as an edit later on. So when you're looking through this catalog trying to find a performance, a polar diagram which is similar to your vessel, you can tend to ignore these spinnaker areas. You can adjust that later on. So yeah, there's a whole suite of these vessels. So yeah, I think with that, I'll leave it here. It's a quick overview of weather routing. You need a few basic ingredients. You need weather, which LuckGrib has lots of. You need to describe to the system the performance of your vessel. And there's quite a large suite of different vessels in the app, as well as the ability to import your own polar diagram. You need to be able to specify to the system what you want it to solve for. And in this case, we give it a point that we prefer to leave to our starboard. And the ability to do that is unique to LuckGrib for isochronal weather routing solvers. And then once you get the results, you need to be able to analyze them in a wide variety of ways. And at that, LuckGrib excels as well. So yeah, there's some more videos coming. Thanks. I'll talk to you later. Bye.